we're going to temporarily steer just a little bit off topic and look at amine oxidation by nitrous acid, but you're going to see how this quickly ties back into the reactions of aromatic rings. So if we take an amine and subject that to nitrous acid, we're going to get a reaction that occurs. So a couple of things. First of all, we're using a primary amine, which means there's just one carbon group attached with an NH2. And the reagent we use is sodium nitrite and hydrochloric acid. Now what happens is when you add HCl to sodium nitrite, you generate HNO2, which is nitrous acid. So that's our active reagent in this reaction. So under these conditions, what happens is this amine is converted to something known as a diazonium ion. And that is a nitrogen triple bonded to another nitrogen with a positive charge here. And because we used HCl, we have the counter ion Cl-. This is called a diazonium ion. The di means two. The azo term is a term for nitrogen. Your original nitrogen from the amine is right here, and then the second nitrogen comes from the nitrous acid. And that's where you get that second nitrogen. We're going to quickly walk through the mechanism for the conversion of this amine to the diazonium ion. So what we're going to start with is the nitrous acid. And it looks something like this, HNO2. And we still have HCl floating around in the solution. So that's going to react with more acid. And what we're going to do is use a lone pair on this OH and protonate that. So now what we have is water bonded to the molecule, and water is a great leaving group that's going to leave. So let's draw a curved arrow in this bond showing water acting as a leaving group. So we'll just put minus water. And what we're left with is N double bond O plus. This is known as a nitrosonium ion. That's highly electrophilic. So now that's going to react with our amine. So let's come down to the next line. Here's the amine. And we have a lone pair on that nitrogen. And we have the nitrosonium ion. So we're going to use the lone pair here, draw a curved arrow to show bond formation. So this is where the two nitrogens get joined together. Okay, so as you're working through a mechanism, you really want to try to think about what needs to happen to get to your final product. And essentially, we need to get rid of this oxygen and these nitrogens and end up with a triple bond here. So the way we're going to do that is first, we're going to do a proton transfer. So to get a hydrogen from the nitrogen over onto the oxygen, and we'll just keep this simple and do it within the molecule. So I'm going to use this lone pair and take one of these hydrogens from the nitrogen. So let's draw in all of our lone pairs just to keep track of everything. So now we get this structure. From here, we can get a double bond between the new nitrogens just by drawing a resonance structure. So if I use this lone pair and push those electrons down and push those up onto the oxygen, we can draw a second resonance structure. So now we have this. From here, we're going to do something similar to get this second hydrogen off of the nitrogen. I'll use a lone pair on the OH and just do another proton transfer. So I'm going to take this hydrogen from the nitrogen. And now we get this structure. From here, we have water attached again, which we know is a good leaving group. So what we can do is use this lone pair on the nitrogen, push that down to form a triple bond, and kick out water as a leaving group. Now we've ended up with our diazonium cation here for our Cl anion. In this first step here, we generated Cl minus, which I can draw in. And that will just come down here and hang out with the positive charge.